Hello, and welcome again back to the OSDC course. I think this is our third meeting, so it probably is going to be the fifth video now, and then we'll have the sixth later on after the break. Let's talk a little bit about the project we finished off at the last meeting of this collecting of CPAN modules, and what was the idea behind that. So let me share the screen. Okay, this is just me collecting my thoughts for today's meeting, but and these are various things. So this is, oh, let me move this around out. Okay, it's gonna be better this way, probably. Okay, so this is our repository, right? Where we have the shared stuff, where I put all the notes from the meetings. I can even update it. I think I've already updated. No, I haven't pushed out the changes. And here's the link to the website. So one of the things I would like to reach is that, and for each one of you participating in this course, you have your, if you added your JSON file, then your avatar is here. So you will click on your link, for example. And then here we would have we're going to have the articles you wrote and published and added to the JSON file. And once you have a list of projects that you are interested in, okay, so I said all the Perl modules that you depend on, but and that could be a list or projects that you're interested in. And then we're going to have a list here of these projects. And in addition, we're going to analyze, so there is going to be some code, okay, that is going to be collecting this data from the JSON files and then analyzing them and putting information here, for example, what languages are there, what kind of issues open issues are there in the projects that you are interested in, okay? And one of the other things that I would like to add here, which is going to be generated automatically as well, is, for example, all the work you have done during the course. So all the pull requests you sent, all the public, I guess. I won't be able to fetch the private ones, and it's not interesting as well either. So all the pull requests you sent, all the issues you opened. So at the end, you will have sort of a page for you, or for each participant actually, of the work you have done, the areas that you're interested in, and so on. And I think that's going to be a nice result of the course, and showing the result of the course. And so that's part of the idea about these projects. And what kind of URLs I'm expecting. So if you go to MetaCPAN, let's say, and you're looking for one of the modules, I think Mechanize is the one that I keep showing, Mechanize. And you find the module, then for many modules, you will find here a link to the repository. Okay, not all of them, not all the modules. And that's one of the things that we are going to learn today, and see why is it missing for some projects, and how can we get them to be added? Because why would you, okay, let's say, why would you want this to be added? Well, if you are looking for the source code of Mechanize on MetaCPAN, and now we'd like to fix something, then it's nice to have a link to the repository, right? So it's just some information in the metadata of the project. And some authors forget to add it, and that's okay. So we only have to find, if we can find the module actually by ourselves, the source code of the module on GitHub, then we can easily send a pull request so the next version of this module will include the information, so the future people will have the link. Okay, but there are other issues there that we can fix. So here is the repository, and then you can, I guess these are various URLs to the repository. How to click, I don't know. So this is the GitHub URL. Okay, it's all generated from the metadata. And so this is so I hope that you will collect these URLs, okay, from the project, which is the home, which is the URL of the repository of this specific project. Okay, so that's one thing. The other thing, and if you have questions, stop me and I'll try to answer. Okay. The other project, sort of what I mentioned, I think, in the first meeting, is that I myself have and 3 projects, basically, 3 repositories right now. And so far, they are just collection of URLs. In these repositories, I'm collecting open source, I mean, in this specifically, open source projects that were published by corporations. Okay, why would you want to do this? Why would it be, is this be interesting? Let's say you would like to work for Airbnb. Okay, so one of the ways you can, one of the things you can do is go to all the open source projects of Airbnb and start looking for issues and start fixing their code. And very soon they will probably call you and say, "Oh, would you want to work for us?" So you won't have to even, I mean, it's going to be easier for anyone who, okay, wants to go to work for Airbnb. And even if they don't contact with you, if you apply, you can say, "Oh, actually, by the way, I already know your code here and here and here. I already sent pull requests." I think having this will give a lot of advantage to someone who wants to work at Airbnb, for example. Okay, so that's one thing. So that's right now. Of course, it's easy for anyone to look for the repository of Airbnb and then start working on it. What I would like to do at one point is to build this similar website that in individual pages for each of these corporations, showing what kind of software they are sharing, okay, what languages they use, how many issues they have. So creating some kind of a map of per organization of technologies and issues. Okay, and the first step is now just collecting them. Here, as opposed to the earlier, because earlier here I showed, in this one I showed the URL to the repository. So it's github.com/some username /some project name. In this case, I'm more interested in the user. It's called organization in GitHub terms. So the first name. So back to the Airbnb case, this is like a user, or it's an organization in GitHub that has several repositories. They specifically had like 195 repositories, so a lot. But so I'm not interested in the direct URL to one project, but to the organization. And similar to corporations, I also have by higher education, so which are various universities and so on, higher education institutions around the world. And I started to collect, and it's not well formatted here. This is just markdown files to collect the data. Okay, and later on the project will go on. But it's easy. So people sometimes, when I talk about this course, this OSDC course, people ask me, okay, but you have to be a programmer to participate. So in this part, definitely you don't need to be a programmer. You just need to be able to collect data and edit markdown file via GitHub. So that's also part of the nice thing about such a project. Okay, and back to the one I mentioned here. Okay, so I mentioned that I would like these pages to be generated automatically from the data. So let's talk a little bit about how they are generated, and that will lead us to the more main content of this meeting today. Okay, so let me go to the source code. Okay, so in the repository, I have a folder called GitHub workflows, and there is a file called CI YAML. Okay, so last meeting we configured the automatic generation of our GitHub pages using Jekyll. And we actually asked GitHub GitHub actually created that file and put it in our repository. And that was a configuration file for what we call GitHub Actions or workflows. Okay, the sort of two names for this. Here in this project, we also use GitHub Actions, and this is the configuration file of it for it. Okay, and let's take a look at it. How does it look like? So this is the configuration file that we have for our own repository. What it does is whenever we push out a new version of our code, so if I edit the README file, or if I accept the pull request for a JSON from one of you, then all the actions, all the instructions that are written in this file are executed on a server of GitHub. Okay, and that's what GitHub Action does. This specifically, what it does, let's go over the steps. Okay, let's go over a whole thing here. Before that, okay, so what it actually does, the main thing that it does is it executes this code, this action. So this action is actually this is located in a separate repository, and I'm going to show you that one. I also have it checked it out on my computer.
So I've got a quick question before you proceed. Yeah. Up at the beginning of the on there, the push and pull request, is that an or? So if either of those things happened? Or is
yes,
that
yes. So I know I had to decide which direction to go, whether to go over the file first, or first show you the program.
Okay.
That is executing. So I'll show you the program, and then I'll go over the whole content of this file. Okay.
Okay.
So we have this repository. Actually, it's called OSDC site generator, and it's in the organization called OSDC Code Maven, just as our project. Okay. So if I go back here, this is the OSDC Code Maven, and this is our project. And now I can open it in the OSDC site generator. Okay, so this is the repository that contains the code that actually generates the website for each of these courses. And it's written in Python, but basically this is but there's a shell script at the beginning, and the shell script runs this Python, the generate py. And on every push, basically, it runs, okay? And here you can find the generate py, and I won't go into it now. I just wanted to show you that this is the code that's being executed every time, basically, I push out a change or I accept a pull request, and so on. Okay? Just wanted to show you that that's here, okay? This source
and that code could be in any language. Just Python was what you happen to pick up at the time. It's not restricted to that.
Exactly. We are going to go over the whole various steps of creating GitHub Actions. Okay, I'm just going to go over. I just wanted to basically show you an example of actually using that. But soon we are going to go start doing GitHub Actions from the basics, but let's go over this file. So for each GitHub repository, you can have several of these YAML files, and they sort of are independently executed, though I think you can create dependencies between them as well. But I usually have only one. So each of these YAML files, and the name of the YAML file doesn't matter. So I call this ci.yaml, but just because I keep using this word. But you can use it. You can have it any name here, any file name. You just have to be .yaml, and also you can have it with a or without a. I have without a, the YAML. Okay, so name. each of these workflows, okay, need a name. The name is free text, actually. This key name is a key, but
Can you scroll your screen to the left a little bit, please?
Oh, sorry. No, I can't, but I can change the size of the.
Yeah, I'll do that because I can't see the left-hand side.
Yeah, okay, sure, no problem. I just that was the edge of my screen. So can
Still
you see?
can't. No, I can just see the bit that says my GitHub token. There we go. That's coming on. I can see most of it. There you go. That's it.
Okay.
That's it. Thanks.
Good. So yeah. Okay. So here name and it's CI. Okay. Name doesn't matter again. It's useful for you, but the keyword, the name is a keyword. So the key here is a keyword. Okay. Then here you can put on, and in various ways you can define the trigger that will cause this workflow to run. Here I said every push. It also runs on every pull request. So it's not when I accept the pull request, it's when the pull request arrives. Okay, and when I accept the pull request, it's like a push. Okay. There's also workflow dispatch here I added. This allows me to go on the website, not this website. Okay, go to the actions. Okay, so this is the website of our project, not the website, the GitHub page. And here I can click on the name that was added here. And now I have a button here, run workflow. This button exists because in the file, I told it that I would like to be able to run the workflow from the UI manually. Okay, you don't have to, but I want. There's also schedule. So you could actually schedule that this workflow would run on every whatever cron job definition you use. Okay, so it's just a regular cron job definition string, and then you can schedule your workflow to happen. So for example, so if it's just regular CI work, okay, continuous integration, then you would probably only want to run it when someone pushes out, maybe in pull request. Maybe you want to have workflow dispatch just to be able to debug something, maybe. But you wouldn't want to have scheduled, usually, okay? Well, except, what if you would like to make sure that even if your project doesn't get any changes, even tomorrow or a week from now, you can still, all the tests are still running. So let's say you configured, you don't strictly configure your dependencies. You say, I need some module in my code, but you don't say, I need this specific version of a module. So maybe the module advances, okay? And if you don't run your tests, you might not find out that that the new version of the module of your dependency breaks your code. So maybe even that, then you would want to have a job that runs every, let's say, day once, and runs your whole tests, and you will get notified by email if this fails. Okay, so you can make sure that even though your code didn't change, but changes in your dependencies don't break your code. Okay, and other maybe more interesting or correct way. Let's say you do fix your versions in your dependencies. Okay, well, first of all, it's usually you only at least in Perl it depends how you do it, but you can fix the versions of your direct dependencies, or you can fix the versions of all the dependency tree, right? Because the fact that you fix the dependency of some module, okay, that module depends on something else, and maybe that dependency is not fixed. And then if that in a deep level some module gets updated, you're still impacted, okay, or might be impacted. So the most correct way of actually fixing dependencies is to fix all the dependencies, even though they are not your direct dependencies, on one hand. On the other hand, you probably want to make sure that even though you're fixed now, you get notified when some dependency changed in a way that breaks your code. So you might have some CI job that on one hand runs on every push and uses your fixed versions. On the other hand, runs every day and uses the latest and greatest of all your dependencies. And then you get notified, and then you decide what you would like to do. Report a bug on this dependency, but maybe that's a bug that they broke your code. I mean, or maybe it's a bug in your code, or maybe it's something else. Okay, so a change in a feature that something got deprecated, and then you'll have to decide what would you like to do, whether you would like to go on and pick up the new versions. But definitely there's a useful thing to have a cron job. Now there are other things. For example, I have GitHub actions that are collecting data. So every 10 minutes they run, collect some data. They actually commit all the data back to my GitHub repository, and then display it. I can show you. Okay, one of them is this project, the cpan digger that I showed you, I think, earlier, and I wanted to talk to you about this later. So this runs every, few hours, goes to MetaCpan, downloads the list of the most recently uploaded modules, collects some data and displays them. Okay, so my code doesn't change, but the data around it does. There's also where is it? The dashboard, the cpan dashboard, which is created by Dave Cross. That also works similar way. So basically you add yourself to this, your account, your MetaCpan account, and it will start showing, that's mine, showing various information about your projects. It's very nice. And unfortunately, very few people actually use this. Okay, but this is another project that does this. It's a very nice project. Okay, back to this one. So this is the trigger. You can define various environment variables. So in this case specifically, my code, or the code that's running here, is going to access the GitHub API. So I needed a GitHub token, but that's something that I would like to keep secret, right? So GitHub Actions, so GitHub, let's go here, allows me, in this case, I did it on an organization level. I can go to the settings, and in the settings, I can say secrets and variables for actions. And I add it here. This is my GitHub token, right? So I can add a new organization secret. I click here, I type in some name, I put the secret here, and that's stored in GitHub. How can my process access it? So this is how it accesses it. This is not an environment variable yet. But this, the env, and then name, some name, this is how I set up an environment variable. So maybe I set up something like this, that I don't know, Perl version 532. Okay, let's say this. So I can set up a variable. But in this specific case, in this code, sorry, not equal sign, colon. Okay, this is how I define an environment variable called Perl version and put the name, the value in it. Now this environment variable will be accessible. Just a second. Okay. Okay. So this okay. So this where I lost it. These environment variables, both of them, will be accessible in the programs that are being executed, okay? And the language of the program, as you asked also, is totally arbitrary. I can use any language here. Okay, I'm going to remove it. This specific is slightly different than the one that I showed you because it's taking from the secrets of GitHub and uses that to define an environment variable. These are some permissions. This is not that important now. What is more important is that you have jobs, okay? And then you can have one or more jobs. The word generate is an arbitrary word, okay? I just made it up. It could be anything, okay? It's slightly strange that this is the way it works, but because most of them looks like everything else up till here, every key up till here, well, except these ones, actually. These ones are also arbitrary, but this is an arbitrary key, okay? This is just the name of the job. And then I tell on what platform to run this job. I can run it either on Ubuntu, on Windows, or on Mac OS. Okay, I can run on either of them. I give some name to this job just so it will be easily identified in the output. Okay, so again, the text here is arbitrary. And then each job needs to have steps. Okay, so in this case, the first step is using, and this is what GitHub calls an action. So there is a slight mix in the naming of things because usually, well, the way GitHub actually used it, that's, I think, the mixing up. So here in the project, you have actions, but these are usually called workflows. Okay, so what you have in your YAML file is a workflow, and then it uses actions. But unfortunately, sometimes also the workflows are called actions, so it's a bit mixing things. Okay, so an action is basically some other repository that has some code in it. This action just checks out your source code. So this, okay, let's go a couple of steps back. So whenever this trigger happens, or let's say on every push, GitHub basically starts you a new machine. In this case, a new Ubuntu machine. And on that machine, it starts executing the commands you gave it. And the first command I told it is check out my own repository. Okay, so this will check out the repository that I am in. So in this case, this OSDC 2023, so this repository. Okay, and then I mean it's almost every time you will want to have your own source code on the server to run something, right? But it's not required. On one hand, you could actually put some code here that doesn't need your source code, and in some cases you will want to check out several other repositories as well. Okay, so that's why
actions is what we're doing. A checkout is the name of a built-in. Where does the @v3 come from? Sorry.
Okay, so what is this? So actions is actually the name of the GitHub user. So the source code of the source code of this one is in GitHub actions checkout. In this repository is the source code. And the v3 can be anything, any tag, label, or even a SHA. So some way to identify the specific version of the code that you're running. Okay, so here is this. Here's the thing. I could have done this. this would say use the most recent version of that repository. This way, I'm saying use whatever is labeled with v3. I could go here and say, okay, let's pick this SHA. Should I think? Okay, this is the SHA. And use that one without the slash here. There's an extra. Okay, and this way, I would know that I use exactly what source, so what version I use. Okay, this is the sort of the safest, of course, because I know exactly. I already checked once what that code does, and now I keep using that. On the other hand, if they make some improvement, any fixes, then I don't get that. Okay, so that's why people usually use one of the labels. It's also, of course, a question of how much I trust the owner of this repository, right? So this is basically this. It also says in the documentation to use v3. So, so it's I didn't just invented that. Okay, they have it. They advertised it. I used to use v2, maybe even v1 earlier. I don't remember. Recently, I upgraded many of my workflows to use the new version of v3. Okay, actually, you can take a look at them. These are here. So releases v2. So these are here. Okay. And you can look at the source code. So exactly, you can actually read exactly what it does. Okay, so this will check out your source code. Yeah, you want?
Yeah. Well, how is it telling it to check out my source code? It's telling it to check out something.
Yeah. So the default. Okay. So this can have parameters.
Right.
Let me show you another repository. So.
Sorry, because I'm assuming this little Ubuntu machine could check out, because this is doing a git pull for us for something, or git fetch.
Yeah, so it does it runs git clone with, I think, a depth of 1. So it won't clone the whole repository, just the most recent one.
Just checking how I understood it was pulling the right code. That's it.
Yeah, so here is another workflow I have that I mentioned before the video of this Ladino website that I'm building. It's a dictionary and a lot of things. So it has a lot of repositories because there is code, there is data, there are audio files. So and I keep them separately. And what it has, here it has the checkout. So it checks out its own repository, this repository. Then it checks out another repository, and here is the parameter. You see, so this is the same action. This one just checks out the current repository, or sorry, the repository where this workflow is. That's the point. Okay, that's the that's the default. And here I actually tell it what repository to check out, and I even tell it where to put it in my file system. So it's going to be a subfolder. This is going to be my main folder, and this is going to be a subfolder. And here I check out another one into another subfolder. So this one actually has, I don't know, like 7 or 8 repositories. And I have to check out all of them. Okay? So this is the checking out the source code. This is needed because I'm creating GitHub pages. Okay, so this is some setup that GitHub pages needs. Most CI work doesn't need this one. Okay, this is actually the first time I created an action. I myself, up till now I was just creating workflows. Okay. But this is now a reusable action, so anyone can use it. And the reason I did this is because I have several of these courses, and I wanted to use the same source code, the same code to generate all the files. So each of our courses will have their JSON data files with the participants and all this information. And then this action is going to generate the file. So this one says that go to the GitHub repository, the user that's called OSDC code maven. From there, take the repository, and from there, take this version and use the code there. Okay. And then there is this one. Okay, that's an interesting one as well. So I don't know if either of you have noticed that once you sent a pull request and it failed with something about the artifacts. It happened to a few people. And then I fixed it. So what happened is that when you send a pull request, because of this, the whole thing starts to run. And it's okay because I want the site generation to run. Because the site generation actually checks whether, for example, whether your JSON file is a correct format. Okay? But then I don't want from the pull request to update the website. Okay? So I said, okay, do generate the pages locally, the new pages, and fail if there is some problem, but only if we are on the main branch, only then upload it to the artifacts. Only then. This one collects the files that the previous one generated and uploads to some storage of GitHub. Okay. I think maybe I picked the wrong workflow to start with because it has a lot of things and many of those that are not really relevant for most of the work we are going to do. So I'll just finish with this and then we'll switch to some more basic ones, okay? Because it was way too complex for being the first one to see, okay? But let me show you here something else. So the first part, the first job generates actually the web page, but it doesn't deploy it. So this is the other one, which is called deploy. Again, this name is arbitrary. This has also the same condition. It only runs if we are on the main branch. Okay, so because you're sending from a pull request, it's not on the main branch yet. But once I accept it, it's going to be on the main branch. And then it says, okay, does some more kind of works and deploys to the server. Okay, less interesting for now. Okay, so this was some relatively complex one. Any questions before we actually? So I would like to show you the more simple ones and get started with those. But if you have any questions, then ask me that.
No, all good.
Sorry?
No questions at the moment. No, it's useful to have the complex one to refer back to later after we've thoroughly absorbed the easier one.
Yeah, we'll get back to it. Okay, so where is this source code here? So actually, I already have it open, but I put it in the README file, so you'll see. Okay, so I have some slides about this, and I can start showing them, and I will see. The link is already in the README. You'll see. So let's just quickly go over. I haven't touched these slides for a while, but I thought I could use them to show. So first of all, they have this thing that I mentioned, that the files, the YAML files in this directory, in this folder called .github/workflows. And so here is a simple one with Python. Okay, so you have a name on push. Okay, so on every push, it will be triggered. There is the jobs. It's running on Ubuntu, And well, it's still using the old one because I said old slides. This one will set up Python on this machine, on this Ubuntu. Okay, which Python? It probably has some defaults, and it probably can get parameters to tell which version of Python to set up. Pip install, it's installing the dependencies listed in the requirements.txt file. So for Perl users, it's like cpan m install, and then you install all the dependencies. Okay, so pip is like cpan m or cpan for Python. This one is just showing the version of Python, and this one is running all the tests that are in this repository. So here, what you can see is there are a couple of actions, but this one, run, is just actually execute this command. It's nothing else. Okay, let me switch to some other example. Where are we? Here. Work, GitHub Actions. Bash. Okay. So here is a more even simpler one. Okay, that's a really simple one. Okay. On certain events, run this. Check out my repository, and then run these commands: uname and print and sort. Okay. So these are just shell commands. In the one that we on the well, oh, you don't see it fully. Okay, sorry. Remind me when you don't see the left hand side. Okay, so in the slide we had the run colon and then a command. So if you have a single command, that's how you write it. If you have multiple commands, you can put a pipeline here. And then, well, it's a YAML file, so that's how you write YAML files. Okay, if you'd like to have a multi-line entry, multi-line values, multiple lines in a value, then you put a pipe here, and then these are the commands. These are the lines of the text. So this is basically a shell script that will be executed on the server. And if I go to the repository, this repository of this project, so actually, I think I have it linked here. No, this is a different one, but okay. This is the repository where we have the one that we just saw. So this one lives in this repository. And if you click on the actions link at the top, this is the result of an execution. So if I click on it, what you see the text. Okay, so sorry, the text here is the commit message. And here we can see the output. So this is the one, the shell view environment. Okay, let me see, just show you. You see, shell view environment. Okay, so name is displayed here. That's why it's useful to have a good name. And here is the output of uname on the server. And oh, so sorry, this is uname, and the rest, this. Okay. This is the result of uname, and all the rest are the result of the sort of the print env and sorted. So this is where you can see that. Okay, just some shell script. Okay. So let's try this one. This is a different example. where so this is a more complex one where that I already use for Perl projects. Okay, this is not the ideal one actually for Perl projects. I think there are better ones. You can configure them in a better way, but I used it for a couple of things. So let's go here before I jump back to this strategy part. So here we say check out version 3. Okay, so use the version 3 of the checkout to check out the source code of the current project. Here we say set up Perl. So there is a specific GitHub action by this user. I don't know who is this person. Okay, that will set up Perl. And you can tell it what version of Perl. And you can tell it also, if it's Windows, then you can tell it if it's Strawberry Perl or the default Perl, which is, I think, active state, I guess. I don't know. So this is one way to set this up. And then I run the shell script Perl -v just to show the current version of Perl. Now I selected the version of Perl, but for debugging purposes, I like to see. Okay, so when something fails, it's good that you can check whether, was it really Perl the version that you were expecting, or maybe there was some problem and it didn't install the correct version of Perl. And then you run in a separate step. I install the dependencies. I check the version of cpanm and I install the dependencies. And then, well, this is some error checking. And then I run the standard thing that Perl modules usually do. So I run Perl makefile, make, and then make test. And I configure these environment variables so even the auto test and release tests are executed. So we're going to talk about testing in Perl in a bit, but basically, when you have tests, this is the way you run the tests in a cpan module, at least the one that has a makefile PL, okay? And some tests are marked basically to only run by the author. So for example, some people include tests that verify, that run Perl critic, okay? And there's no real point in running these tests on the end user's computer. Okay, so for this, I need also a little bit background here. So when you install a module with cpan, okay, it comes with all the tests, and it automatically runs all the tests that come with the module. Okay, unlike in, I think, every other language. In Perl, they run it. Now, this is actually a good thing. Oh, it also has costs, but it's a good thing because now it will verify that at least the tests that the author has are passing on your operating system, on your version of Perl, on the dependencies that you have installed, and so on. Okay, which might be, most likely will differ from every other system. The drawback is that it takes a long time. Okay, running all these tests, relatively long time, especially if you have installed hundreds of modules. So as an author, I will say, okay, some of these tests are not really interesting on your computer. Shall I run the spell checker for the documentation on your computer? There's no point. Okay, it's not going to be really different, the correct spelling on your computer from mine. Okay, except if you're having British English and I have American English, let's say. Okay, or broken English, and then that's different. But so that's why these tests, some of these tests, depending on an environment variable, will skip some of the tests. But in the CI, I usually want to enable them. So that's that's the reason I set the environment variables. So to enable all these tests. Okay. Good. Questions so far?
No, that was a good one. Getting onto some Perl.
Yeah. Just a quick one. You had in one of the configuration files, you had some like matrix dot something for. I
Oh,
think
sure. I missed the matrix.
I just wondered where that was defined. Because I remember
Okay.
you had sort of like
Okay,
secrets.
no. It's here. Sorry. No,
Oh,
no.
okay.
I
Okay,
forgot
now I
to
see it.
come back. Okay, so in the previous example, and even here, I said runs on, and I explicitly said what operating system to run. But
Yeah.
GitHub actually allows you to create a list of values, and if
Yeah,
you have
okay.
two lists, then it becomes a matrix. Okay, and if you have three, okay, so you have variables, and in this case, I created a variable called runner with a list of operating systems.
Yeah, okay.
A variable name called Perl with a list of version numbers, and then I can use these as variables in my workflow.
Yeah.
So
okay.
basically, what happens here, and let's just disregard these three lines for now. Okay. So in this case, what will happen is that I have 3 times 2 versions, right? 3 operating systems, and on each operating system, I have 2 versions of Perl. So when this runs, GitHub Action actually will start 6 instances. Not necessarily in parallel, because they have some limitations. I think they run only 3 in parallel. But then once finishes, then you will get a new one. Okay? So this is only, and I guess you can change this limitation if you pay enough to them. But basically, in parallel, or theoretically in parallel, they will start 6 machines on the 3 operating systems and with the 2 Perls. And then inside here, you're using them as variables. So here I'm saying, okay, runs on, and it will take the current version from this list.
Okay.
So this way, and here it will say install the version from the matrix that's currently executed. So in the 6 versions, that's how I create the 6 different versions. Okay.
Yep.
And
so there's one. Can you use that substitution variable, that matrix.perl, in the name so it comes up in the step report?
Yeah. So it's in the name here.
Right. Okay. I was looking at the next slide down, but that's the same thing, and that would come up on the same report in Git to show you the status of the steps.
Yeah. So let me go to this to the repository if I find it. GitHub subgub, GitHub Actions, Perl makefile, and I have this for makefiles, for build.pl, and for this Zilla, just this example. So this is the actions, and this is the output. So this is the most recent run. Actually, I have it scheduled, but if nothing happens, then I think after a month or 3 months, they stop it. But it doesn't really matter. So you can see this is the most recent run, and you can see 6 versions. So on the title, you can see the title of them, and then inside you can also see probably maybe it's not here, but here. So this is the title, in the title. But you could use anywhere these versions, so you could echo them, you can whatever. Okay. Actually, 5. Sorry, it's only 5, not 6. And the reason it's 5 is, and that's the exclude. Okay. So you can say, okay, here are these 3 times 2 versions, but not in this pair. Don't run this pair. Why? Well, specifically because Strawberry Perl 5.36 hasn't been released yet. So there is 5.30, but no 5.36. So I am excluding it. Of course, it might be that your program doesn't run on that specific pair of whatever, okay? Or you can say, okay, I don't care. At the end, it costs money. Okay, so if it's an open source project, then Microsoft pays the bill for now, at least. If it's a closed source and you are a private repository, then you have, I think, 2,000 minutes free, but then runtime, but then you start paying. So you don't want to waste it on versions that you don't care, right? So that's why you might want to limit or define the matrix in a different way. So you can also, instead of defining a matrix, you can define the individual pairs or triplets or whatever that you would like to use. That's also a way. So, okay. And here is this fail fast. So what does it do? By default, it's actually true. It means that if it's true, then if any of the jobs, so any of these, of the 5 now, fails, then GitHub will stop all the others and we won't run new ones. So as soon as one fails, it's done, which is saving CPU time, but maybe you don't get enough input because you don't know now if the rest would succeed or all of would fail. So you have to think you have to decide what to do with this, okay? Right. Let's have a break. Okay. Any questions before we go to a break?
Nope. Nope. That was a very good example, and I understand that one now. That was good. Thank you. Good context.
Okay. Good.
Good.
So let's have like 10 minutes break, and then we continue. In the meantime, think about more questions. Okay. Okay. So
Bye.
bye in the meantime.